I'm going to be talking about solving trigonometric equations. A trigonometric equation is just an equation involving trigonometric expressions. For example, minus 2 sine theta is equal to 1. To solve an equation like this, we want to find every possible value of theta for which it holds. Starting with an equation like this, we can divide both sides by minus 2 to get sine theta is equal to minus 1/2. Now we already know that sine of 7 pi over 6 is equal to minus 1/2, and sine of 11 pi over 6 is equal to minus 1/2. Additionally, if we draw the graph for sine, then we can see that the line at y equals minus 1/2 will only intersect it twice between 0 and 2 pi. This means that we've already found all the solutions between 0 and 2 pi. However, we know that sine is periodic with period 2 pi, which means that any solution is also a solution if we add an integer multiple of 2 pi to it. This means that our solution is theta is equal to 7 pi over 6 plus 2 pi n, or 11 pi over 6 plus 2 pi n, where n is any integer. Since all trigonometric functions are periodic, it is often the case that we'll find solutions that occur periodically. While solving trigonometric equations, we can use all the algebraic techniques that we've learned before, and we can also use trigonometric identities. However, some of these techniques can produce extraneous solutions, so we need to watch out for those by testing to make sure all of our answers actually work at the end. Let's look at another example of a trigonometric equation. Suppose that we have 3 cosine of theta plus 5 is equal to minus sine of 12 theta. This equation looks a bit complicated to solve, but before we start using trigonometric identities and jump into it, let's just look at it for a minute. We know that minus 1 is less than or equal to cosine theta, which is less than or equal to 1. This means that 3 cosine theta plus 5 is going to be greater than or equal to 3 times minus 1 plus 5, which is equal to 2. We also know that minus 1 is less than or equal to sine theta less than or equal to 1, which means that minus sine of 12 theta has to be less than or equal to 1. Even though we have sine of 12 theta instead of theta, multiplying the angle by 12 is not actually going to change the amplitude of this function, so we still know that it's less than or equal to 1. But this tells us that minus sine of 12 theta is less than or equal to 1, which is less than 2, which is less than or equal to 3 cosine of theta plus 5. This means that one side of our equation is always less than the other side, no matter what theta is, so there can't possibly be any theta where they're equal. So now we can see that trigonometric equations tend to behave more oddly than other kinds of equations we've seen already. Just now we saw that this equation had no solution, and the previous one we did had infinitely many solutions. In general, it's useful to graph both sides of the equation before trying to solve it to see what kinds of solutions you can expect to find. For example, in this case, if we drew a graph, then the left side, 3 cosine theta plus 5, would look something like this, while minus sine of 12 theta would be something more like this. So we would have been able to tell ahead of time that these don't intersect anywhere.